Hi there folks, in today's demonstration I'm going to show you how to flatten or explode nested arrays in Power Automate on scale so that it's efficient using my favourite action, select, and some string manipulation techniques. So you can see on screen right now on the left hand side I have an array and that has some nested arrays with product IDs, and ultimately on the right hand side I have a new array that contains an object per product ID, so that John, who has two product IDs, has now got two objects. So traditionally you'd use nested apply to eaches, but I'm going to show you some advanced techniques in the form of today's demonstration. So if you haven't already, please make sure you like and subscribe, and without further ado, let's jump into the demonstration. So here I am in Power Automate, and at the top of my flow I have a compose action, and that has a data structure. And if we pop open the raw inputs, we can see the data structure. It's an array. It includes an object or multiple objects, of which each one is for an order. So I have the customer name, I have the order number, but then within that I have a nested array, which is the product IDs array. And there are two product IDs in this particular array. Now ultimately what I'd like to try and do is to explode or flatten this nested array so that I get an object per product ID. So if we look at Jane as another example, she has three product IDs, therefore I'd expect to get three individual objects. And then if I was to use that data, I could have a CSV file that would have 3 lines on there for each of those product IDs. Or if I was creating a row in a table in Excel, I would have 3 individual rows in that table. Now in terms of what that data should look like, if I move further down my flow, I have a compose action here, and if I pop that open, you can see the data structure. So John Doe, he had 2 products, therefore there are now 2 objects. We've got Jane Smith, she had 3 product IDs, therefore she's got 3 objects. And I'm going to demonstrate to you 2 different techniques. The first of which is down the left hand side, a traditional technique using nested apply to eaches, and then down the right hand side using some string manipulation and one of my favourite actions, a select. There are 6 actions to achieve this flattening or exploding of data. And what that means is, by comparison, the left-hand side is going to grow in terms of the number of API calls when you run it on a larger data set, and also probably exponentially grow for the number of minutes, hours that this flow could potentially run. Whereas on the right-hand side, using those 6 actions, it is going to work across massive data sets and only require those 6 actions. So it will never grow in terms of the number of API calls that are required. So in order to put that into a bit more context, I have an Excel file and I have that same data structure. I have 10 records, of which John Doe has 2 product IDs and Jane Smith has 3. And I'm going to try and turn that data into a structure like this so that everyone has a row per product ID. So John has got 2 rows, Jane Smith has got 3 rows. Now you'll see on the right hand side I also have a table in Excel. I'm going to write the final data output to this Excel table when I run that flow to demonstrate it working. So back onto Power Automate, if we have a look at the history of this flow, you can see that in order to loop through those 10 individual orders, it took 9 seconds. So it didn't take too long, but if we have a look at the right hand side, all those actions currently are showing 0 seconds. So rather efficient using that technique. So if I go in to edit that flow, I have a compose at the top, and that has my data structure. This could be from Dataverse, it could be from SharePoint, it could be from a third-party API. It doesn't really matter, but I've made it a fixed data source at the moment and used a compose. For the purpose of the demo, I've used parse.json based on that data structure that's in the compose, and then I've initialized a variable, and I've called that order line for each product. Then in order to understand the apply to each, for each of the orders within the parse.json, in this case, I'm going to have a nested apply to each and then have a look at all the different product IDs within each of those orders. And that's why we have these nested apply to eaches, which ultimately enables me to append to the array that I've created using values from the customer name for each order, the order number, again from each order, and then the product ID, which is based on each product ID within that second nested apply to each loop. So if we have 10 orders and there's a multitude of different order or product lines, we're going to have 26 instances of this loop running in the form of nesting. and that results in 26 API calls. The compose is just the output of the variable, so I could check that the output was as desired. So it's a rather straightforward flow, something you'll probably see an awful lot of, but if your data structure is to grow in size and you're using thousands or tens of thousands of objects within a data structure, this is going to consume an awful lot of API calls. It's going to take an awful long time, and you'll probably end up losing a lot of hair as a result. Now, if we jump back up to the top of the flow, you'll see that over on the right-hand side, I've got the history, so we can explore that whilst looking at the right-hand side method for achieving this with 6 actions. Starting from the top, I have that original compose that has my array, but then if we go down onto the first action within that right-hand side branch, we have a compose, which I've called array with string, and it literally is an array with a string. It's just a string that needs removed. And we need that string in an array for the technique that I'm going to demonstrate. And hopefully all will make sense as we move through these 6 actions. So if we look at that from a history point of view, you can see it is literally just an array with a string. And I've called that a string that needs to be removed. You can be creative as required. The next action is going to take the original array, which is the outputs from the compose, and then I'm using an expression called setProperty. And so what setProperty does is it takes an object as the first property, it takes the name of a key within that object, in this case product IDs, and then it replaces it with a value. And I'm replacing it with a union of the product IDs, which is item product IDs, and the outputs of the compose array with string. So if we have a look at that from the history point of view and pop that open, we can see that the original input, we have our array, which is John, his order number and product IDs, of which there are currently 2. But then if we look at the output, we can now see that we've added just a string that needs to be removed into that product's ID array. And this is the useful piece that we're going to use in the next action. As I scroll down, we can see that Jane is the same. She's now got 4 product IDs, and then Bob has got 3 because originally he had 2 product IDs. So on to our next action, it is another select. And this is a very efficient way of transforming or manipulating data. It's looping through all of those objects. And so the input is the body of the select with the array with the string that's been added. And then the expression, again using text mode, is based on this time a join. So what a join does is a join takes an array of values and it joins it based on a string or value that you provide. There are 2 properties. So I'm taking the product IDs, of which John now has 3 because we've added that string that just needs to be removed into his original product IDs array. And then we're adding to that a concatenation of some pipes, in this case 2 pipes at the start, 4 pipes at the end, and this is important also, and I'll explain later on. But in the middle, we're using remove property, and we're removing the product's IDs property from the original object. So the original object contains the customer name, the order number, and also the product IDs as an array, but I'm actually removing that now so that I don't have the product ID in this particular data sample, because I'm going to re-add it in one of the next actions, but based on each of the individual product IDs. Now, if we look at that in terms of the history and have a look at the select, we'll be able to see the input, which is our output of the select from above. Of course, that includes our customer name, the order number, and the product IDs with our just a string that needs to be removed. But you'll see the output is far more complex now. And so what's happened is it's created a string. Now, the best way I can describe this is you might use a join if you're concatenating email addresses and inserting a semicolon between it. So what we've done here is we've taken the individual order number and then we've joined it with 2 pipes and then the original object of the name of the customer, the order number. And then we do that again with 4 pipes and add in their next order number, again with 2 pipes and their customer name and their order number. And then you'll see we have that final one, 4 pipes, and then just a string that needs to be removed. And the reason that we do this is join does not insert the value that you're looking to join with at the end of the string. It only does it in between all of the values within an array. So if we did a join with just 2 objects, in this case with John, product ID 12345 and then 23456, we'd only join in the middle. But because we've now got 3 products, we join in the middle of the 12345, the 23456, and the 23456, and just a string that needs to be removed. Again, hopefully all will become clear as we move through this flow. Now, the other thing to call out that's very important is I use 2 pipes in the middle of the join, and that is to enable me to split both the ID from the original object, but I also use 4 pipes at the end here, and that marks the end of each object in our join. So you'll see that in the string. And probably the best way for me to explain this now is to open up this into something like Notepad and break it down. So I'll copy the output here, and with it popped into Notepad, we can see the data structure that's being created. So we still have 10 individual objects in an array, but within each of those objects now we have a string concatenation by using that join. And that string concatenation is split by 4 pipes. So I'm highlighting 4 pipes there. If I do a Control-C and Control-F and paste, we can work our way through each of those 4 pipes, and you can see where they are. They're at the end of, or in between, each of the individual objects. So if I highlight an object on screen right now, starting with the order number and moving all the way to the end here, we can see where the next 4 pipes appear, and we're going to use those 4 pipes to our advantage to split this string again back on the 4 pipes. Once it's split on those 4 pipes, we can then split on these 2 pipes that we have within those new strings, and that will enable us to get the order number and insert it back into this object that we have created as a result of doing this join. So each of these order numbers that we see, which are all unique, for instance, this OP89012, this QR90123, and also this ST01234, we're going to insert them back into each of their respective objects using a select. And then the last value of each of these strings, which is just a string that needs to be removed, we will of course remove using a filter array. So back over onto Power Automate, I'll just make my way down through this flow and we'll move both left and right. So we're going to have a look at a join, and that join is going to be based on that select, and we're joining with 4 pipes. Now we've already joined with 4 pipes within our select, but we have 10 different strings within that structure that we created. If we now join with 4 pipes, we're going to end up with one massive long string of all of those values. So if we have a look at the output of the join, we can see the input, which is an array. We're asking that array to join based on those 4 pipes. But if we look at the raw output, and I'll copy this into Notepad, and if I paste that in, you can see now we have just one massive long string. And actually, if I enable word wrap, we'll be able to see what it looks like. This one string, which is based on the body, is all of the 10 different objects that we had before, but now with 4 pipes inserted at the end of just a string that needs to be removed. And if I highlight there, you can see there are 4 pipes, and there are another 4 pipes. And so with all of this joined together, we can now split again on the 4 pipes, and rather than get back to the 10 original objects, we'll get back to 26 individual objects, because we've created the individual objects here with 4 pipes, splitting the nesting or the explosion or flattening of the arrays using 4 pipes. We can then split by those 4 pipes and get back 26 individual objects. So next up, we're going to have a look at a filter array, and we're doing a split on the body of the join based on 4 pipes. That will give us 26 objects, but within those 26 objects, there will also be a number, or actually there'll be 36 objects. There'll be 10 different strings that we need to remove that are based on just a string that needs removed. So I'm using a filter array based on item, open close brackets, is not equal to just a string that needs removed. And I used a string here in that original array rather than an empty array because I thought it made it easier to understand and also easier to find. So I can easily remove those strings from the array. In order to make sense of this, if I jump across onto the history, we can have a look at the input, which is based on that split. And if I pop open the input, we can see we have that array of all of those strings and just a string that needs removed. So after each of the customers, you'll see there is just a string that needs removed as we work our way through that array. So at the moment, these are just strings. They're stringified JSON, and we can turn them back into JSON. But what the filter array is doing is taking that split based on those 4 pipes, and then we are filtering out just a string that needs to be removed. And so if we look at the raw outputs, we can see now we just have those 26 individual strings, including those order numbers and also the customer names. So finally, we jump across into our last select, our 6th action. We're using the body of the filter array as a from. We're in text mode again and using add property. And this time what we're doing is we've got a combination of expressions here, but we're splitting the string that we saw in the history, which in fact, if I reopen as the output from the filter array, we are splitting on these 2 pipes by using this expression here, split on the 2 pipes. And because we can then select the values, which are either on the left-hand side or the right-hand side, they're referred to either integer value 1 or 0. So the first one is 0, the second one is 1. And then we're able to create or update the original object with the customer ID. And so we're able to add a new key value into the original object, which includes the customer name and also their order number based on this split. So by splitting, we're able to get the second value here. We're using the integer 1. I'm converting that into JSON because it is a stringified JSON. I'm then going to use add property, which is going to take that stringified or now converted JSON, adding in a property called product ID, and then I'm going to use split once more, but to get the first value, which is integer 0, which is our order number, and it will add it into that object and give us 26 individual objects with those customer names and of course their product IDs. If we're going to have a look at the select and the history, we can see the raw input again that contains all 26 individual strings, and then because we're doing that split and also then adding a property into the JSON version of this customer name value that we have here, if we look at the raw output, we can see that we now have a lovely array of customer name, customer orders and product IDs, and John has 2, Jane has 3, and Bob has 2. Now in order to complete things, I then have an add a row for each of the objects within the select. So the body of the new select is the input to the apply to each, and then in the add a row into a table, I've simply used expressions for the customer name, the order number, and then the product ID. And that's of course based on the structure of the array that I've created, and I am then adding a row into the table. So if we save and we test this flow, we can watch the flow unfold. We can see that the actions on the right hand side have actually already completed, and I'm already writing that data to Excel, whereas on the left hand side the nested looping has finally completed after 13 seconds, and of course this will grow exponentially based on your data set. But if we jump across onto my exploding data, we can see that those individual rows are being written to the Excel table as expected and matching that sample data set that I created prior to my demonstration. So I'm hoping that I've demonstrated to you some advanced techniques in Power Automate in order to manipulate the data, stringifying it and then converting it back into JSON. But by doing so, we've achieved the same thing that's taken potentially 26 or more API calls based on the size of your data, but 6 actions that will be scalable, can work on large data sets. And in fact, I've seen it being used on the Graph API where there were tens of thousands of records being brought back. There was a requirement to flatten that data, and where it took 20 or 30 minutes before, it was taking 10 seconds using this new technique. So something to explore if you've not tried before. It's definitely an efficient technique. And if you're looking to write data to Excel in bulk, do not look at using a method like this with an apply to each. go and have a look at one of my videos on how to write data to Excel efficiently using either the Graph API or Office scripts. The last thing to call out with this new array that is created, if we have a look at that raw output, with the product IDs, for instance, there could be a need to relate that data to the details of those individual products based on the product ID. There is also an efficient way to join arrays, and again I have a video on joining arrays efficiently without using an apply to each. So not only could you flatten your data or explode your data using this technique, you could then join your data using one of my other videos and achieve some transformation in Power Automate using a very minimal number of actions, but also very efficiently using the number of API calls that you have available to you in your license. So as always, I hope you've enjoyed this demonstration. Thanks very much for watching to the end. If you have any thoughts or feedback, please do leave them below, or any more challenges, do let me know. But otherwise, thanks for watching, and I hope to see you again sometime soon. Cheers.